All right, my beautiful young children. Remind me at the end of the so, your exams real quick, I did one quick. I'm about 4 papers done. So, I did one of those today. Done with the other guys. I'm talking about, I haven't analyzed anything, I just go through it very quick, so I read almost question by question. So, question one, I'll read it. Like I said, I wouldn't know. I just put numbers in. I'm making a reflection at some point. I think that's something really important. I'm learning something a little bit. That's everybody try to what I can do better, that kind of stuff. Why? I mean, I used to do it at the end of the year, but why do it at the end of the year? Just quick little form idea, but I'm making that over time. That's wrong. That's what we said all the time. I don't want to put anything. I will say, everybody in class too. You guys are taking now. Everybody, let's keep going. And everybody took it. $7. Everybody was doing $30. And everybody was doing that's one reason I agree with everybody. That's a really, really good move. That's your we're going to start with chapter 1. It's important because you got to know how to do all that stuff. I felt students several times in the year, you probably do. If some student asks me a question to go, if I'm going to miss it, I'm going to miss it. Too much reading, not able to get in, I get lost after you, and I'm not passing. Being careful is really put on. This kind of, I would say, my good thing, I start with it one reason because I think that's important for us to know how to gather, do all that stuff. Also, insight, kind of focus on ideas, but I try to say, when you're ready to do it. That's how it is. Our book actually, starts off with like a 1.0. 1.0. 1.0 introduction. You'll see on homework tonight, you'll see a 1.0 and a 1.1. I put it all in there together. 1.0. For introduction to stats, so now picture this as, day 1 type stuff. So some of the stuff I'm going to go over today, you actually already know because we talked about it in chapter 4. Just kind of understand it, that's how things are. This is really just looking at that, chapter 1. So we know how to gather the data. Now we're going to look at the data. We're going to look at the data in chapter 1, we're going to look at the data in chapter 2, we're going to look at the data in chapter 3. So 3 chapters of looking at data, again, big picture, basically, that's what you need to understand about looking at it. So definition of statistics, what statistics actually is, before we do the definition. And so it's something that, again, we won't ask you, but if you would rather take in this course, I can help you out in one time, what's important about this. It is a science. It actually doesn't say it's in mathematics. It's a science. Okay? It's a science. It's a science and a art. Not mathematics. Right? It's a science and an art of doing these main things: collecting, analyzing, and drawing conclusions. Collecting, analyzing, and drawing conclusions from data. Collecting, analyzing, drawing conclusions. And I mentioned that there's four main topics. Collecting, that we've already done. We've done those collection parts. Now we're going to analyze it. We're going to analyze it in chapter 1, 2, and 3. 4 we already did. Then we throw in another part of probability, because you have to understand probability to understand that kind of thing. It's called the drawing conclusion part. So they don't actually put that in part of the definition of statistics of probability, because you have to understand that part. And so we do probability in chapter 5, 6, and 7. And then it takes sweet. And then we're going to draw conclusions. Draw conclusions is pretty much after the big fascinating middle. Like I said, I won't talk much about chapter 4 anymore. Yeah. Now, there may be a question on there just to kind of get us making sure we remember about it, right? Mostly when that happens, so you guys got 2 pre-response questions. Pre-response 1 had an A, B, and C. There was a B part, but you have not been taught the B part yet. And that happens, right? So there may be a pre-response question at some point that will bring chapter 4 back in. I'm not going to prep you for it, and I wouldn't maybe say, not remember how to do it necessarily, but not remember how to do it. But I'm going to do it because I want to make sure that you guys remember it. Right, okay? An individual, okay, an individual, we talked a little bit about this one already in chapter 4, but it's that object that we're doing all this stuff on. The object describing the battle. The object is describing the battle. Maybe it could be a tree, it could be a car, it could be a student, it could be whatever we're doing in life. Okay? Concrete, a house, whatever, it's that object describing the battle. And you do the place for that. Okay? I don't know. I probably should do this kind of definition. Variable. You guys learned what a variable was in mathematics probably somewhere around 7th grade, 6th grade. X, right? In statistics, the variable is the same back then. The number that changes. What kind of a this is? It's an attribute that can take on different values. It's a variable, right? It is that height of a tree. That's a number that changes value. It's your GPA. That's a number that changes value. Okay, that's what that variable is. I think like we do talk a little bit about that in chapter 7. It's the response variable, right? We have a response variable in chapter 4. That was the response that we could get. The height of the tree. So that's what that variable is. Right? That number changes. None of this stuff is going to be on per se. You need to know this. Right? Now, this is new to us. This is new. So in variables in mathematics or in statistics, we have 2 different kinds. One of them is called categorical. Categorical. It's when I put it into a category. It's when you put it into a category. The color of the car is categorical act. Right? It's a categorical act. And then the other one is called quantitative. Quantitative. I don't like to call it quantitative. I like to call it numerical. One of the books I have, one of the called numerical. Similar. Quantitative, numerical. When we get a number, when we get a number or we get a category, and that's going to be important all year long. Is this categorical data? Is it numerical data? Is it categorical or is it numerical? It's not a trick. It's not a trick. You need to understand what that is. And in chapter 7, chapter 8, chapter 9, 10, 11, if you know the categorical and numerical, then you know the process that you have to do. So the categorical, you have to do this process. The numerical, you have to do this process. And if you do this process, you're done. Not first. It's really, really important to understand is the categorical and numerical. And at most times, later on in the year, when you say, I dealt with this, I think the first question I ask is the categorical and numerical. Categorical and numerical, that's not a description. Okay. So, category, put labels in it. Put labels in it, right? I just color a card. This is category. It's putting you into a category. Gender, categorical down. Okay. Your grade level, even though that's a number, that's a category for that. Like when you're a junior, that puts you in the junior category. When you're a senior, it puts you in the senior category. So there are numbers, however, that put you in the category, not necessarily in the number. Okay? And quantitative, they take on counts of values and measurements, counts and measurements pretty much. You're counting something or you're measuring something. Count or measure, and that puts you in the numerical or quantitative. Okay. So that question, this is what one thing you would question about. You need somebody to deal with it. In the quantitative, you learn to distinguish, I mentioned this already, you can learn to distinguish and categorical and quantitative variables. Now, it's kind of like a big reward later. We expected to analyze categorical and quantitative variables correctly on your exam. Under quantitative or numerical, there's two different kinds. And so one of them is called discrete. Discrete. We've got a tough time with this later on. Discrete counting. You can take on 1, or 2, or 3, or 4, or 5. Counts. Basically, that's how I remember. If I'm counting something, it's continuous. If I measure something, it's continuous. You can take on 1, or 2, or anything in between. Anything in between. There are times where this variable and this variable are part of the thing for different things. It's okay. And you can make it discrete continuous. You can make it continuous discrete. Part of the thing. You can make it discrete. This is a picture of this, right? You got a bunch of data, and you're trying to make a graph. So you want to make a continuous graph or discrete. That's pretty much what it's trying to do. This is not that big of a difference. As long as you know numerical quantity. Question. I'll come to the number. Is that too slow or okay? Categorical, numerical. In numerical is discrete continuous. Sometimes there's a debate on what that variable might be. So discrete continuous. There never should be a debate over quantitative and numerical. So quantitative is categorical. There might be a better way, but it's not necessarily wrong. There is a wrong between quantitative. Okay. You tell me. I've already given you this. I tell it all. Categorical or numerical? Categorical. Okay. Is that categorical? Whatever it is, right? The number of calculators owned by students at UHS. Quantitative is discrete continuous. Discrete. You can't have one at a time. You can have 1, or 2, or 3. So you count things is discrete. Okay? And that is discrete. Zip codes. Categorical, which is not category. You know, that's a number, so sometimes that's confusing. Right? Just be careful. Like the grade level, zip codes, that puts you in a category. That puts you where you live. Right? We don't do something on 2. You're closer to town, so if you do something on 3, you're out over the 3. So if you do something on 4, you're out over the 3. quantitative, count it, or you measure it. Measure it, right? You can take, you can take 1 minute, 2 minutes, or anything in between. Okay, that, again, that could be debated. If you want a round, then you take it from continuous to some of the street. Yes, it's typically things you measure. Again, the street count. Oh, yeah, you can't take on anything. So you have a gap. The time machine, time machine. This one gets debated. So the appraised value of the home and first of all, that's categorical in that. That's what that. Now what the street is continuous. If you've got money, you'll make it. However, if I'm making a graph of this, I'm not making a discrete graph. That makes sense. Because if I make a discrete graph, I basically have to have discrete graphs or bar graphs. Well, not bar graphs. The graphs that have like a dot. So I've got to have a dot for every single value of the home. Probably not. So I'm probably going to make it. I'm going to make it a category. 100,000 to 150,000. That makes sense there. So just kind of understand that. I think that makes sense. But then I always just go back to the counting. The other question on this, I think is counting. Distribution. Distribution. That is a word that's probably used more than anything else. Okay? And I will bet you whatever I have on the AD test is going to say somewhere describe the distribution. I guarantee it on the next step describe the distribution. Distribution tells us what the variable is and how often it takes it. Typically a distribution of a graph. Typically a distribution of a graph. It could be a table. But the distribution is just that. It tells us what the variable is and how often it takes it. It tells us what the variable is and how often it takes it. That's what a distribution is. It's a picture of the data. It's a picture of the data. The distribution. Okay? I have a lot of data here and a little bit of data here and a whole lot of data here or hardly any data here. Right? That kind of stuff. Right? That's what a distribution is. Describe the distribution, but you want to describe basically what the picture looks like. It starts lower with the size of the lower. So, it tells us what the value of the variable is and how often it takes the value. Distribution. Distribution that variable does is how long it is. Okay? That's it for 1.2. Hopefully we can identify individuals. Hopefully we can classify variables. Okay. All right. So let's look at analyzing categorical data. Analyzing categorical data. That's 1.1. Praise that here with 1.2. Okay. So this one's pretty easy. This categorical is the easiest of the two. Because there's only a couple ways we can do categorical. What? Oh. That's 1.1. Yep. The advantage is practice. I think put headers on stuff. Put different headers on 6 pages. I'm sure I'll fix it this year. here and look at it. Okay, so this is the first one you have. Sorry. You have to watch, look. Province, Saskatchewan, Ontario, Alberta, so I'm guessing we're looking in Canada. Gender, male, female, male, female, male, female. Number of languages spoken. 1, 2, 3, 4. Handedness, right, left. Height, centimeters. Wrist circumference, I don't know. Preferred communication, in person, cell phone, text. Okay with that? So, I have a person, I'm guessing, that I've got information from. Where do you live? What gender are you? What gender do you identify as? Okay. Number of languages spoken. Handedness, what handedness are you? I'm both. How tall are you? What is your risk for something different? Some of it's numerical, and some of it's quantitative. Okay, that? I do that a lot. Quantitative, I'm not sure numerical category. Where you live? Category. Gender? Category. Number of languages spoken? Numerical and then speaking. Handedness? Category. Height? Numerical and speaking. Again, I don't think I'm going to have a dot for each individual. I'm probably going to make it somewhat continuous. Wrist circumference and then preferred communication. With all that, I just want to look at the preferred communication. Okay, I'm just going to look at that. So those values are the variable that I'm looking at. Preferred communication. This is the frequency table. So my choices are cell phone, Facebook, in-person, text messaging, and the frequency tells me how many each variable occurs. That could be considered a distribution. That's called a frequency table. It's just telling me how often it occurs, how frequently it happens. Okay? Again, it looks a whole lot nicer here than it does here because there I can't see a whole lot. And I can do it, but I have to enter the county one, and I have to try to remember what that one was. And it's not that bad because it's only 10, 15, whatever. If it was 200, that would be very confusing to see that. We need to get a picture of it somehow. So there it is right there. Those 4 including the there we go. Now I know how many I have. I know the highest is text messaging. I know the next is in person and the 2 goes together. Now I increase this side. This page is by all the goals. I can see all this stuff. Just tell me more information. You could see frequencies, how often it occurs. You could see relative frequencies. And anytime you see the word relative in front of it, it's changing into percentages. Changes frequency into proportions or percentages. And a lot of times, percentages are more helpful to us than frequencies. A lot of times, proportions or relative frequencies are better than frequencies because it turns it into proportions. And the portions are easier to grasp. I don't have to put a row up to 4 or 3 or 2. Now this is bad. If it was 200, and then there was a 100, and then there was like a 6, just picture the left-hand column over here, right? I don't want to go all the way up to 200. If I turn it into proportions, my highest one is 1. That's all I'm saying. I got to go back to the y-axis. Ooh, man. Well, I don't want to go all the way up to 200. I'm trying to really and I just have to do 1. So that's the difference between the two. Relative frequencies turn frequencies into percentages. So we know there's 10 of those factors there. That's 20%, 10%, 30%, 40%. That's the frequency convert. If you got that calculator, you can convert that fairly easily. Okay. In statistics, most of the time, they don't care if you go to a decimal, they don't care decimal, fraction, or percent. I typically am pretty much happy with decimal. In statistics, over that. I think it would go 2. Most of 3 to 3 out of it. So I say 3 if it's 0.00005. I don't want to say it's 0 because this is 0.0005 is somewhat important. Okay, well, so that's why I don't say 3. I just say make it was important. If it's 2, put 2. You want to put 3, but 3, D, you can put 1. I don't care. They're not going to gain you to put 2. So you improve that over 3, you're not going to do it. To display categorical data, there's 2 ways. Bar graph, circle graph, pie chart. Bar graph or pie chart. That's the only way to display categorical data. It's the only way to display categorical data. It has to be a bar graph, and it has to be or a pie chart. And the pie charts are hard to do pencil and paper. You almost have that on a computer. It's not intuitive for us to draw 5 to 10% and 20%. It's hard. Now, 25% I can draw one pretty easy, 50% I can draw one pretty easy, but the difference between 10 and 20 starts to get a little easy. So it's a little bit harder to make it on a pie chart than it is a bar. You kind of need to know. Okay? You need to know that if you have categorical data, it has to be one of those. It has to be one of those. Okay? And so I'll talk about a bar graph really quickly. I don't think they're going to make you spend time to make it. They might do it for homework. I might do it for money. I'm not going to waste time on a test. He's not going to waste time on a test. You spend 5 minutes to draw it up. And basically, you do it right away. You know how to do it, you don't know. They may ask you what you do on the bottom. They may ask you what you do on top. I don't know. I don't think they're going to ask you to know. We kind of understand all that stuff. We spend 15 minutes on that how to make a bar graph. I'm just going to understand that bar graphs do have graphs between the bars. They cannot touch. But it doesn't matter what order you put those things in. I put those in any order whatsoever, and that kind of makes our graph look different. That's why you have to understand the difference. And really, when I'm talking numerical, is why it's like this different. Okay? Because, I mean, you can't say our triangle goes because somebody else is not start going to go high. You can't do that depending on, depending on what you're going to go around here. So bar graphs have that gap. And again, notice that this one's percentage is related to relative. I think that's easier to do than it is to make it going all over the place. If I had 200 people, it would make this hard. The percentage would be only 1, 1, 5, 2, 5, 1, 7, 5. And they're not going to make it, as long as you're close, they're going to stay. But sometimes you just have to estimate. That's why it's pretty much. So, category data, draw labels, axes. The categories typically go on a horizontal, but you can make it. You can make a bar graph sideways. Put the numbers on the bottom and they can go out. So, again, how you do it, they don't care. This is the wrong bar graph because the categories are on the bottom. They don't care. They go out this way, but very few times they do. Okay. So, vertical axes, scale them. That's important. And when you scale them, you should make all the bars look the same. You should make one of them better. You should not. These should be common to both. Those are things that they're going to try to fix. ADP is going to draw one on 3 on the next question, right? And they're going to draw one of these bars way down here and one of these bars way up here. And they're going to say twice when you go here and here. And this one is 20 and this one is 21. And we're going to do things like that to try to make sure that you're reading it and understanding what it says. Reading that. Okay, that's where we're going to try. I'm going to say that tricky. We're going to make sure you follow the point. So make sure if it's starts at zero, whatever this one is, and that's the same number. And that's what a trick is. They don't make sense. Okay. So scale the axes. The vertical axes is always at zero. You keep the intervals, draw equal bars. Bar graphs are difficult to look at, and then you have to replace the bars with pictures. Be careful in this lead, be careful about your very draw huge mathematical variable windows and none. Another one goes up to 350, where this one is 100. So really, 3 times the two. But that looks like it's 5, 6, 7, 8 times bigger. So it's misleading. Farms built in more cows, right? In 1970, it was 19 cows. In 1980, it was 32 cows, 2 cows, and 1992, not 32. And this down here is 1, 2, 3, 4, 5 cows. That should be close to 100. If that's 20 times 5. So just recognize this type of thing. There's a 3-dimensional bird. This is 63%, that's 38%. I'm not sure that doesn't look like it's just numbers a whole lot more twice. And that's good. Publications do this all the time. Here's a video. This is actually on the news. This is video. This is a presidential election. Describing categorical data, this is important. You're going to be asked to describe the graph, describe the distribution. I told you already. Guaranteed you're going to be asked that question. Describe the distribution. So you need to first know is it categorical, is it numerical? If it's categorical, that's what we're talking about. 1. You need to do this. Talk about the highest thing, talk about the lowest thing, talk about something else. Remember, you want to in order to get each, you need 3 things. These 3 things. So we're going to talk about it. Something, right? Talk about, just try to talk about 3 things. And typically, the 3 things that they look at is something high and something low, and then something else. Make it up. Yep. That's all numerical. But we don't care about that. Yeah, we don't care about the range. So we got that in just a second. Text messaging is the most preferred, with Facebook being the least. In person is pretty close to text messaging, and I only know one more, so I'm not going to talk about it. Okay. Typically, talk about the high, talk about the low, talk about something else. I'm kind of changed away from that. You talk about the high and the low when you're in context. Always, 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 always in context. What are we talking about? Right? Text messaging is the highest, with Facebook being the lowest. When forms of communication of these students. Okay? You should be able to explain what it is without that person having to go up into the problem and see what we're talking about. That's what I mean by in context. It doesn't have to be a novel. It doesn't have to be a novel. It's enough something where I don't have to really go up inside there and see what we're talking about. Forms of communication for these students or these people, I don't know what they were, right? We did a good job of that. Text messaging was the highest with Facebook and Twitter. So it doesn't have to, like, it doesn't have to be a novel, it's just enough that we're in context. And that is in context, in context, in context. In context. Okay. You could see a side-by-side bar graph. That would be if you had, maybe I had the text messaging and the form of communication, and I did a bar for the males and a bar for the females. Okay, and then sometimes we can do comparative. Display that uses the category combined with another category, these bars are grouped together based on the value of the category. Please don't write all that stuff. Get off of that, please. It's two of them. But it's not here. That's side by side. So, yeah, you can touch these here, but you gotta have the gap between them. Great. Okay. So it says snowmobile use. Never rent or own. So never use a snowmobile, they rented a snowmobile, or they own a snowmobile. Around here, my guess is never would be putting on that. And because these are all the two more, but the gap is between you and okay. This is percent over here. Okay. Again, I don't do 1 through 100. I typically do 1, 0.5, 1, 2, 5, and 7, 5. Okay. So in this particular one, this is environmental club membership. So these people were in the environmental club. So if you're in the environmental club, those never were the highest. I've never been in this club, I've never been in the environmental club. It's probably a little bit more conscious of the environment. Yep. You got the misses, and those, y'all okay, side by side. If you're going to compare those, if you actually describe those, you're going to compare them. By far, the never, or the people that are in the environmental will never die. Almost twice as high as the one. Just something. Okay? You could see segment bar graphs, so it's kind of like, I would call stack bar graphs, like this. Same information except for the stack. Okay, so now I can see the 100%. It's a little bit harder to read. However, if you see the measures and all them, it's harder to compare. It's not that big of a deal, but you got stack, you got side by side, segmented. This is a new one that they had 3 years ago. This is one that they talked about. Okay. Okay. It's a modified segmented bar graph in which the width of each rectangle is proportional to the number of individuals in the corresponding category. That sounds good. You have a picture there, although when it's black, it's hard to see it all. But your picture looks like this one. Okay. Really. But here's the nose, which looks like about 80%. So this is 20%. This one goes up to the 70%, this one goes up to 35%. So mosaic plot, it typically looks like a rectangle. Okay? It typically looks like a rectangle. And it's kind of going out to 100% here and up to 100%. You can see that there are a lot more people that are not in the environmental club than were in the environmental club. But the ones that were in the environmental club were a whole lot better. But numerically wise, they're probably pretty close to the same. Because the percentage is so much lower here. Okay, fine. This one they wouldn't ask you to describe. I think this one they would ask you. They added that to my previous work, and let's say a couple on that. Just kind of recommend. Modified segmented bar graph uses the width of a rectangle is proportional to those numbers. So it's just like this one. It's just like this. The height is just like. The only difference is now this one comes out of here, and this one comes out of here. Now it's telling you there's a whole lot more nodes. This one I can't tell. Okay. This one it looks like there's a whole lot more nodes here than here. So it's proportional. So I really don't know the numbers. I just know proportional. Now I can see what I'm not doing a whole lot more because it's not doing that this level of work. Okay. Compare the highest, compare the closest, compare something else, be specific. Okay. Remember three things good. I'm going to not show you all year. Three response starts with three things. And sometimes context is one. So, just something. Okay. Comparing it, we should use relative frequencies. So if you're comparing, right, if we compare and make sure we change the proportions. That's a don't change the numerical, right? Because let's just say this is 20 males in this class and 10 females. The male bars are going to be taller than the female bars, no matter what. No matter what we're doing, we're going to be taller because it's twice as many and harder to compare. More males are like more males are like two. There were more males than more males. So it's turned into relative so we can compare. And then you're describing it, be careful, and don't you say there's more of it, because you don't know there's more. That's the message. Like, what can be said about the above graph? There were more students that like you don't know. Unless there was a mosaic, right? Okay? You don't know there's more students, you just know there's a greater percentage of students. That's one of the reasons. If you look at it, you look at all the places, and all that. No, not all. Any one of them. Okay. Hey, what do you got? That's for me? Okay. If it worked out a lot better, so, whatever you okay. This is that same information now, okay? This is that same information. I'm not so gosh, dang. 15, 26 people. Now I know how many people there were. Okay, so this is called two-way table. You were either in the club or you were not in the club. And then you were either use it or you didn't use it or whatever. So it's called two-way table. We use it a lot. We use it a lot. But it's really done. I can see there were 16 people that were in the club that never owned it. Now you can kind of see why there's an 80-20 in that mosaic spot. There are a whole lot more people that are not in there than that. Okay? So that gives you a numerical representation of that graph. That's why I have to apply those nodes as soon as you like it. That's correct. Y'all good with all that stuff? Don't worry about that terminology. What proportion of the students are not in the environmental club? What? not in. Not. Okay, fine. Good? So we're going to take that 1221 and divide it by the 1526. Good? I guess I don't know that. Okay, that's the question. Again, they call it marginal frequency. I don't. The names mess up too more than you can do that. Okay. That's good. What proportion of students have never used a snowmobile? None of those cats did. Okay, none of those cats did. Again, 10-4. I don't know if it's a 0, and I don't like to present them. And I don't like practice because that doesn't tell me really do them. Just under that. Again, don't worry about these things. Don't worry about these things. What percent of the people are environmental club members and on the snowmobile? And we have to do both. Be in the environmental club and they own the snowmobile. Those cats right here. And it's out of still out of all of it. Okay? Again, this is not that big of a deal yet. The drafting part of it is. But they're leaving us in the thing for the future. There's just some questions on that. Again, so read these carefully. What percent of environmental club members in the sample are snowmobile owners? Of environmental club members. They're telling you that they're environmental club owners. Okay? You have to read that carefully. I'm no longer talking about everybody. What percent of the environmental club owners? I'm only talking about those cats right there. Are owners. So that's 1,600 that we get by. You can see that you're good. You have to read that carefully. What percent of environmental club members? Okay, so the environmental club, I don't care about these guys, and I don't care about these guys. I'm telling you the environmental club members. And those guys. I will say that if this was a free response question, you cannot just put that. They want to see this. If you left it like that, that's what they want to do to the delivery. And I'll probably do this and then do this. But they don't want just that. They don't want to make it up. If you want to put this and do this, you're okay. If there's a question like this on the homework, you start listening to it, you start doing it. So, I think I took it out, but here's the whole thing, so it's probably still on there. I hope you can make and interpret bar graphs. We've got to go down and identify what makes some bar graphs misleading. This is the misleading one. Calculate the frequencies in a two-way table. Calculate the conditional frequencies. And then use the bar graph to compare the conditions. Describe the nature of the association. Big things bar graphs. Categorical numerical bar graphs. Circle graphs, because we want to do that. You should see 1.0 and 1.1 here.